And our job as farmers is not to have a perfect soil test. I've learnt so much about soil biology in the last 15 years. None of this stuff I got taught at university. We only taught soil chemistry.
So within that time, we've got it looking like from that, in a year and a half, to that. And we've been working on this paddock, so I think obviously the bacteria and the fungi and that were there, but it was just so all it needed was reactivation.
We have all these free-living nitrogen-fixing bacteria in our soil, but they need air. So, without air they can't operate, and they need to have a healthy home to live in for them to do that job of getting us free nitrogen. So, the protozoa are really important. They're cycling that nitrogen. The bacteria are actually storing. They've got a really high carbon to nitrogen ratio. So the bacteria hold a lot of nitrogen, and if there's none of those nematodes and protozoa to eat them, they're not cycling it, in a form that the plant can use.
You're still feeding your livestock underground, so it's giving them at least something.
So when we're putting on these inputs, we're actually creating the perfect conditions to need more and more of them, and that's part of the challenge. We all have come to realise we need more carbon in our soil to improve the health in every level, and if we can get paid, that's a bonus, but it's going to pay you to have it. That's driven by photosynthesis. There's two aspects. There's a decomposition cycle, and there's a liquid carbon pathway that Christine Jones has written a lot on, and you can Google her work and read a lot on it if you want to know more. She has shown that the most quickest way to get carbon back in our soil is through this liquid carbon pathway. It's nearly 6 times quicker than the decomposition of just leaving residues on the surface. So if you're just leaving residues on the surface and not seeing your carbon increase, that's because you might not have green solar panels at the time. And so when we have no actively living growing plants, we're creating sugars, but if the ground's dead, what happens to the carbon that those plants have just put down for us? Yeah, the bacteria who don't go anywhere, they need food, and so they eat our soil carbon. So if we aren't feeding them and we haven't got living plants, our soil carbon cannot go forwards. So if you want to improve your carbon for whatever reason, you are not going to do it without a living photosynthesizing plant. Ongoing drought, fire, what we noticed was a lot of nitrate accumulated weeds like nightshades everywhere. We've never seen nightshades ever, because it's usually a sign of a different soil to ours. Did anyone else see lots of nightshade after the drought? Yeah. What I believe happened was all of our soils became very bacterial, and when the bacteria then there's no protozoa to feed on that bacteria, they dry off, release the nitrogen in their bodies without it being cycled in an available form for the plant, and it gets, these nitrate weeds come to mop it up. But when we've got good protozoa, we don't need that mopping up because they're cycling that nutrient more effectively through the system, if that makes sense. So they're really, really important, and often if you've got that nitrate accumulating weeds, some down south that have capeweed or things like fat hen or nettles, different nitrate weeds will often indicate that these guys are missing in your soil food group.